Hello and welcome back to my tutorial series. In this episode we will start to use Generative Shape Design, which is a model in CATIA. And by the end of this video you will learn to design this fully parametric sheet metal part in surfaces. Now, solid body design in CATIA is pretty much on par with any other software out there, but surfacing is where it truly shines. The reason why surfacing is so useful is that it pretty much gives you an unparalleled level of control when it comes to creating complex shapes, and it can be adapted very easily to fit your specific workflow and match your specific requirements. Now, we have already covered this in the introduction video, but while working with surfaces, we need to work in geometrical sets. And geometrical sets are a lot messier than body elements due to the fact that they are not ordered, meaning that the order of operations inside the set does not necessarily need to be from top to bottom like it is in solid bodies. Also, elements don't tend to be nested inside other elements like they do in part bodies once you use them. This is why it is very important before you even start working to organize your tree and keep your geometrical sets clean and even rename the operations whenever possible. You can obviously do your own thing when it comes to organizing your part structure based on personal preferences and how much time you actually want to dedicate to your part. But I will just show you what I consider is a good start from my own personal experience, and you can just take it from there. Just know that a good part structure can save you many hours of work later on. So when you start to design something, it's always a good idea to imagine what you want to design. Now, you don't actually need to imagine anything because you can see it on my screen. But when you design something on your own, you need to have a mental picture of what the end product will look like. And after that, you need to mentally split your part into multiple features. So looking at this part, that would look something like this. You will have your base surface. This is generally a mating surface. This can be 1, 2, or even 10 surfaces, depending on how complex your part is, or it can be something totally different. But this is the basic idea. You will have something that is usually a functional surface, which is this one that you design yourself, you define yourself, and then you usually have some way to connect those two surfaces together, which are these two walls. So you can see how in this part they are split into different areas, and these areas are all located each in their own individual geometrical set. Good. So let's start with let's continue. Good. So let's continue with the part structure that I have proposed for you. First, it's a very good idea to have a geometrical set with input data. This is where you will put your input geometry, like wireframe or even surfaces. This would be the most likely, in this case, it would be the most likely origin of this surface. Considering we are designing this from scratch and without context, I'm drawing this myself. But for a part like this, you would probably receive this from someplace else. Then you have your construction set. In the construction set, you most likely need to put a subset with features, and for each feature, you would create another geometrical set, as you can see here. I have one set from the bottom surface, and I have renamed this. One for the top surface, rename this as well. One for the side, and one for the other side. We have this reinforcement here as a different set, and this set for the holes. After these sets, I have another set where all of this comes together. We assemble all of these sets that we have individually built. We only now at the end of our tree do we assemble them together. We start joining them and creating our final part. After we have created our final part and we are happy with it, we will use this for a thick surface operation inside our part body. We choose the thickness and our part is ready. Good. So now let's start building this from scratch. This is generally part where you will not find the drawings because of the complex shape. These are some general dimensions that you can work with. So to start drawing this, we click File, New Part. We go to Part, hit OK, enable Hybrid Design. Now we start organizing our structure here. Insert Geometrical Set, Input. This will actually be empty for now. We have our construction set, and inside our construction set we will have a subset named Features. Inside the feature set we'll begin with, it doesn't matter right now, we will just rename it later. We have this final assembly stuff, and then I don't like this order, so we will right click the part and go to reorder children and put our part body at the bottom. Good, so let's start with the bottom surface. We right click properties to rename it, bottom surface. We create a sketch on this plane. We see that we have one line, one level, one Z level here, and one Z level over here. I guess this one was like this. Now, these dimensions over here are not that important. All we need to do to take into consideration regarding this is that when our part sits like this part will not be part of the will be outside of our actual mating surfaces for the part, right? So this actually here is absolutely not important. We just need to make sure that we have nice and round surfaces that don't cause any tangency issues later on. We can make this as long as we want. I know we said we need to fully constrain the parts, but the sketches, but this time it's not really that important because it's already way bigger than what we need. And we've noticed that we made a little mistake here, and we've put our sketch and extrusion in the wrong geometrical set. That's not a problem. We can select them both with Control, right click, and change geometrical set. Change it to this. You click No to put it inside, and then hit OK. Right, I did not explain this well, but let's just delete this. The way you create kind of like the equivalent of a pad in surfaces, is with extrude. Extrude takes a sketch and extrudes it along a direction. When you select the sketch, it'll automatically select the normal to sketch option, which in this case it's the YZ plane. And you then select the length, go in one direction and the other, and click OK. And then you have your surface. Again, put it in the wrong tree. In order to create all these surfaces where you want them, you need to right click and define in work object. Now, it is always a good idea to have like a join. A join is usually used to join multiple surfaces, but here we can use it like a tree structuring feature. You just hit join and create and select this. You could join multiple surfaces together here, but now we just use it to join one. And then we create a join. And we know that this join is basically the output of this set. Right? So we can even rename it if we want to, like bottom surface. And then we use this as a bottom surface. So every time we can change something here, we change in the sketch, we can add features, we can add a lot of stuff, but then we will edit this bottom surface, and then we will remove this like that, and we will select something else, and the part will just automatically update. Good. Now that we created our bottom surface, we need to create our top surface. We create another set. We name it top surface. We make plane, or better yet, no, we create a sketch on this plane like that, and then we have a line which we constrain to be a certain distance from this. 60 seems about right. Then we use the extrude command again, and there you go. We can color these differently and continue with the other surfaces. Now that we have our top surfaces, top surface and bottom surface, we need to connect them somehow. So we click this again, insert the geometrical set, click no to be inside, and we name it side, let's say L for left. And then we create a line like this, which we constrain to be 40, I guess 40 is too much, 30 millimeters away. Right. Now, this line, we need to basically have it angled like this. We could do an extrude, but then we would need to create another line to get the direction. What we could do is a sweep, but first, if we want to sweep this line, first it would be, I think, a very good idea to project this line on this surface so we know where the starting point is. It will allow us to control the surface better. So in order to do that, there is a command called project. Projection. You click on the projected element and on the support. In this case, a normal projection would be fine. After this, we need to create an angled surface. We do this by using the sweep command. In the sweep command, you need to select your profile type, which matches your input wireframe the best. For us, it's a line, like this. Here on the subtype, the most, by far the most common one is with the reference surface. Now what this does is you select the line, the guide curve, and you select the reference surface. And after this, you can select an angle, like this, and this will sweep this, will basically create a sweep according to this line with the 80 degrees relation to your base surface. Now our surface here is flat, so this is basically a plane. But if our surface wasn't flat, then this would pretty much be a wavy surface, making sure it will respect the 80 degrees angle in each and every section of this line. Good. We can have this a lot longer than what we need. It doesn't really make a difference. We can color this like that. Same as before, we create another geometrical set. We call this side R. Here we can hide this because it's really annoying. Now, here we had something a bit different. We had a line going like this at an angle. Let's say 30 degrees. Sorry. We need this angle to be, actually I think we can constrain it like this with the dimension towards the origin, or maybe not, or maybe we need to do this instead. Okay, now we need to do a sweep. As you can see, this line I have not projected onto this surface yet, and even if I would project it, it will be, let's try and project it and do the same. So project this line here. See, it ends up on the curve. I don't like that. If I do the same, here, see, we have the issue here. Why? This is because it will try to keep the same 80 degrees angle even on this radius here. So we can use another set, another subtype, which is with draft direction. Here we can choose the draft direction as the Z component. And we don't need to click the project, we can take the sketch directly. Our guide curve is the sketch, and our draft angle is the Z. And we can go ahead and delete the projection. Good. Now, this wall here had kind of like a break in it. It wasn't all one surface, so we need to create the other one. We could do it in the sketch like this, and just create a different line here, and then do this, but we will not do that today. We will create another sketch. Something like this. and then we will sweep this again with the drive direction. Good. Now we have our two sweeps. What we need to do is create a radius between them. You can do that very easily in surfaces with this one, shape fillet command. So if you click this little arrow, you see you have the edge fillet, which works kind of like the one in the body, the part body design, where you click edges, and you also have shape fillet, where you can select your two surfaces that you want to fillet. You select the first support, you select the second support, and you need to look straight on like this, and you can see that you want your fillet to be here. That means this one should have this direction, which is good because it goes like this. But this one here, this is not the good direction. You want this to be in this inside as well. So you click this to have the good directions for everything. And you can see it creates a radius here. This is 1 millimeter, but so we need it to be a lot larger than that. Let's say 20, and click OK. Good. Now we have our second wall. Now, what's left to do in our final geometrical set? We need to join these together. So the way we do that is by going here into this set and using the shape fillet again. We take this left wall, we take the top surface, we make sure the directions are in like this. This time we put 6 millimeter radius and hit OK. Good. This looks very well. Now we take this fillet that we just did, make sure this is in, make sure this direction is in, otherwise this is what happens when one of the directions is wrong. We don't want this, we actually want like this. And for the final one, this needs to be in the radius, it will be like this. And if you follow all the way this surface here, this direction will be here, which is exactly what we want. And this one needs to be up. Okay, we need to see what's wrong in this area. I guess it doesn't like this very much. The fact that it's going on this radius here. So when you get an error like that, it usually has to do with CATIA not being able to generate the fillet. It's most likely has something to do with this radius here, or it has something to do with this fillet pointing into the other one here, which it doesn't really like. So first thing you do is try to do the same thing, but change the extremities here to minimum. And you see that doesn't work either, for some reason, right? If that fails, we need to change this geometry a little bit here. So first thing first we need to do is change this to 0, because we said this at the beginning of the video that this is not really that important. And we also can do this, change this to something like that, and we need a small radius here. So this way, when it tries to create a fillet here, it's not pointing towards the other fillet around here. So it does have its work quirks, CATIA, and you probably need to learn all these essentially debugging methods. There you go. So, I don't know if you can tell by now, but this looks exactly like you want it to look like. This is actually perfect. This is the first step in which you create like the base surface from which you will cut your part. So after you have this in the feature tree or wherever you want, you create another geometrical set and you call this trim. This set will contain the trim for your part. Better yet, we can actually have the holes first. We create this set called holes. For this hole, there's a very easy way to do it. You can just create a point. Usually this point is in the middle. You want to keep it here in the middle. Just move it a little bit further up in X, somewhere up to here, let's say. Maybe a little closer to the surface. It doesn't have to be perfect, just close to the surface. After this, you can create a line. You can choose this surface here that you have already created, which is basically the final surface, but untrimmed and without holes. Create a line. The line definition is normal to surface. You create the surface, you select the surface, you select the point, and this needs to be very long. Then you create an element called intersect. Intersect creates a wireframe at the intersection of two elements. In this case, between a line and a surface, it's going to be a point, but this can be a curve as well. So you have this. And on this line, you can actually create a sweep. This is where we extrude a circle along the line. But using sweep, you don't need to actually create a circle. You can go here, circle, center, where is it? You can select center and radius. You select this as the center, and let's say 4 millimeters as the radius, and it creates a cylinder, basically. This we'll use to cut our part later on. Now, going back to the trim. In the trim, you can basically split the trim as you did the other features, if you want. If not, it's perfectly fine to do it however you feel like it. It all depends on how much time you want to spend on this. Sorry, I clicked something wrong. We will create a new geometrical set, call it trim bottom. In this set, we'll create a sketch. And then we need to do something like this. And then something like that. We constrain this to be like 30, that's too much. 15, 20 millimeters. This point needs to be like 5 millimeters away. This is 140, that's not right. 145, no, 150 looks about the correct angle. This can be as low as 5 millimeters or even less. And we have one side of the trim. Now we create another set. And we can call this top trim, but we'll have to rename it afterwards. Here we will just cut like the base of the trim. See, we have our point over here, which does need to be inside our part, but our part is going to be way less than that. We just need to have a little tab growing out of this part. We don't need to have the whole part going like that. So this can be actually much lower. It can be 30 millimeters. We can have this like that as well. We said this is going to be 150 degrees to match the other one. We need to constrain this really well here. And then create a radius of 5, like that, just like that. Perfect. Good. We can call this top trim. Now we can extrude this trim like that. And in this top trim, you can add another sketch. And then you can draw this tab here that you want to grow out of the part. So this is gonna be probably like 95 degrees because it's closer to that. This is probably can be a little bigger. We extend this like that. Then we can project this point, the intersection point, and then we can constrain our little tab to that. So this is going to be 10 millimeters. This is going to be 10 millimeters. And then this is going to be 10 millimeters as well. See, this is going to look a little different than what we have initially drawn. This is going to be 5. This is going to be 5 as well. Good. We can go ahead and extrude this. It doesn't like the fact that this is not a construction point. No? Looks like I didn't make it a construction point. You can go here to user edges and click this point that you have projected and make this a construction point like that. Good. Now you have this feature here, and you can combine these two shapes. I can show you a different way to combine them now. It is with the trim command. You select one of the shapes, you select the other one. You can select more of these and it will just trim them all. And you can already see that it basically cut through these through this middle part here, and it made a combination of the shape. And you hit OK. And now, because you have a sharp corner here, sharp edge, you can use the edge fillet command, which works exactly as the one in body. You select the edges, select the value, and hit OK. Good. Now you insert another geometrical set, And here you need to define the other areas. By the way, just to make it a little bit easier, you can change the color of this set, the surfaces in the set, so you can see a little bit better. So now you can actually use the surfaces that you already have and create an offset from them. So you can select this purple surface here and create an offset. The way you do that is with the offset command. You just hit on the surface, click on the surface, select the direction, and select the value. And you can see that we have very large issues because it doesn't like to be offsetted this much, which is kind of a problem, to be honest. I did not expect to experience this many problems on the first part. What you need to do in order to fix this is to basically cut away some of these excess surfaces that you don't really need. How do we do that? Well, we select this edge here and we make a parallel curve. We have this option where you click this, select the curve you want to parallel and the support, which is this surface. And you go with this all the way up to here. Maybe a little more, if you can get away with it. Okay, then you use the split command, where you select the base surface you want to split and select the parallel line. And now you have a split of this surface. And then you should be able to easily offset this 35 millimeters, just the way you wanted it. Good. For the other one, for the other side, you go to the sweep and you offset the sweep 35 millimeters again. And we see that we have actually forgot about the bottom trim here to make this extrusion. Good. After this, you go ahead and make another geometrical set here, which is the trim result. And you basically combine all these surfaces like this with the fillet, the shape fillet command that we already learned about. Now we go ahead and go into our final assembly geometrical set, and then we split this with our trim result, and we also need to select this sweep. You can see this trims it the wrong way. You can just select the sweep and click on other side. Hit OK, and this is your final part. What you need to do now is go to part design and select this option, back surface. It tells you that you have not defined part body as in work object, but it'll do so automatically. You select the thickness, you select the surface you want to make thick, hit OK, and you have your very own design of the bracket. Two things to notice now: that we have not really made this, we have not respected the height of this bracket. It looks very different, but like I said in the beginning, this is a parametric part, and you are able to do this, to change this very easily. like so. You take this sketch, which defines the top surface, and you reduce this to, let's say, 30 or 35 would be a little more accurate. You update the part and everything just changes. The other thing to note is that we have not yet defined our reinforcement here. Our initial part had a reinforcement. We call that a bird beak. So you can go ahead and add that. It doesn't matter. It's very easy to add it later. You go to the feature tree. You insert. Sorry. You go to the feature tree. You insert another geometrical set. You name it bird beak. You can hide the part body so it doesn't cause any confusions. Here, the bird beak will be basically based on this surface and on this one, but you don't want to use the final surface as an input. You always want to use the latest input from each feature, which is this one and this one. You already have this line here, but again, you don't want to use it. You switch back to your generative shape design. You create an intersection between this sweep and the bottom surface. You need then to create a point on this intersection, which is going to be somewhere inside the part. On this point, you will create a plane, which is tangent to this one, normal to this curve. And then you create another intersection where the first group of elements is this surface and this surface, and the second one is your newly created plane. Good. So just so you don't get confused, I'll hide the unnecessary parts. On this one, you then create two new points. One is going to be on this line, and it's going to use this point as a reference. Let's say 8 millimeters, sounds about fair. And on this one, you do the same thing, maybe 5 millimeters for this one. Then you create a new line through these 2 points, which will be the direction of our newly created rib. You take another point, a plane, through this tangent to this curve. It doesn't matter where you put it. And then you create a sketch. You can hide these surfaces. Create a circle, 6 millimeters or 5. You constrain this circle to one of the points. You create 2 lines like this. You make sure they're tangent to the circle. You put a maybe 60 degrees angle on them. You can change that later. Make sure you have an axis here to allow for symmetry. And then go to the quick trim tool and delete this. You can extend this a little bit like that. And there you go. This is beautiful. Maybe it's a little too much. We need to move this, make it a bit smaller. Now, you need to find your untrimmed surface, which is this one. What you need to do is insert this bird beak before you trim it. You need to insert it in the tree somewhere here. So the way you do that is by toggling this one, which is insert mode, and this will basically create uh, another operation in between this one and the next one. So you insert it, you click on shape fillet. This one, support 1 needs to be the first, the untrimmed surface, and the support 2 is the new rib. You can put 5 millimeters as a radius, and you see that you have not chosen the direction correctly. Doesn't matter, this can always be changed. Oh, no, I don't want the bottom surface here. Sorry. This can always be changed. And you can all see that it's in the wrong tree. You can put this later in the correct position. You hit Ctrl U to update everything, and there you go. Now you have your very own sheet metal part designed in surfaces, fully parametric. So thank you for watching this video. I hope you enjoyed it. Please subscribe if you haven't already, and like this video if you want to see more content like this. Thank you and have a nice day.